Hi, and welcome to 8th grade math. This is going to be your first screencast you'll do for me. And we'll start you off with a pretty easy one and some stuff you probably already know. So this is basic equations. Our unit is equations unit. And we're going to start off with some of the most basic practices that you've already learned in past years. But we just want to make sure that everyone is on the same page coming into this. If you notice, every one of my videos has a learning target, and there's a learning target spot on your Cornell notes, and you just copy it. So it's not something you should have to figure out, so it should be pretty easy to have that accomplished when you come in. So you want a title, basic equations. You want the date. The date is very important, probably more important than your name, but you should have your name on it anyways in case you accidentally lose it. And then your learning target. So all that stuff is just basic fill in the blank information. It's not something you have to figure out. It should be there every time. And your learning target today is I can solve two-step equations and check for accuracy. That obviously involves one-step equations too, but we went for the two-step equations and check for accuracy, and that is a check. And I know you've done those before too. So we'll start with this one. It says 3x minus 5 equals 13. And just as you learned when you first learned algebra, you always do the opposite. You want to get down to this x right here so that it's by itself. So it says x equals something. We want to know what this missing thing that's being multiplied by 3 and then 5 is being taken away from it, and it will magically equal 13. And we do that by doing the opposite. We undo what has been done to the x. So the first thing you want to do is do the adding or subtracting when it's a two-step equation. So right now, x is being subtracted from, 5 is being subtracted from 3x. So we want to undo that by adding it. But because it's an equation, it has to be added to both sides. So this goes away. Now I'm trying to write this as neatly as possible because this is how I want you to write. You don't want to skip steps. You always want to show each and everything that you've done. So this is not a step that you can get rid of. I don't really know what that meant. Okay, so we want to write what's still there. The only thing that's not there are the two 5s that got crossed off. So what's still there is 3x, still an equal sign, and now I can add 13 and 5, and that makes 18. Alright, and then we have one last step to do. X right now is being multiplied by 3. We want to undo that. To undo that, we divide by 3. That is the opposite of multiplying. And because it's an equation, we do the same thing to both sides. So 3 divided by 3 becomes 1, and everyone knows 1 times anything is itself. So we don't need to write 1x here. We just need to write x equals, and 3 goes into 18 6 times. So there we have our answer, but we don't know for absolute sure yet if it's perfect until we do a little check. I'm going to scroll down the page a little. Maybe. Alright, so I think I'm scrolled down as far as I can go. That's okay, we can squeeze it in here. So what you want to do when you do a check is you want to kind of separate it so that it doesn't look like part of the solving of the equation. And you want to rewrite the original problem that was given. I usually do this above, but I ran out of room, so I say check x equals 6. So it's kind of narrating my own work. So I know that as I'm checking that x is really 6. And then you plug it in. You don't do any algebra step. This is more of an order of operations problem now. So instead of 3 times x, I have 3 times 6 minus 5 equals 13. Well, 3 times 6 is 18 minus 5. And I'm running, I got no space here, but I know that 18 minus 5 is 13, so my last line should be 13 equals 13, and the famous check symbol means you did it, you know you're right. Alright, we got one more to do, and that'll be the end of the video, so I told you it was going to be super short. And I chose this one for a certain reason you'll see in a minute. So right now, what's being done to the x is it's being multiplied by a negative 4. And I know that looks like minus, and it is minus if you read it 7 minus 4x. But if you just look at x, it's not being multiplied by just the 4, it's being multiplied by the negative 4. Because that negative is not a part of the 7. But we're still going to get rid of that constant first. That's what normal numbers are called. They're called constants. So we're going to get rid of the constant. It's a positive 7. This negative does not belong to the 7. So, by the way, all these little lines and stuff, you don't necessarily need to write them in. Sometimes I do that because I'm talking about it. Doesn't mean I write that when I do my equation. So I'm going to subtract 7 from the positive 7. That's going to make it go away on this side, but I need to subtract 7 here as well. And why this is important is because when I bring this 4x down, you can't just do this. Then we never use the negative. So it's still being subtracted from that side. So we still need a negative stuck to the 4. Equals 20. And now when I divide by a negative 4. If I did not include the negative, my answer would be the complete wrong sign. 4 goes into 25 times, but a positive divided by a negative is always a negative. So I'm hoping I'm right with negative 5. And again, I didn't leave myself much room here. But I have 7 minus 4x equals 27 for my original problem. I'm going to check it with, and I didn't write this right, check x equals negative 5. I want to see if that's right. So I'm going to plug in a negative 5 right here. Now just be really careful here with the two negatives. You got a negative and a negative. So when they multiply together, that's going to become positive. So a lot of people get confused. They keep this negative there and they say 7 minus 20, that's not 27. But really it's a negative 4 times a negative 5 is a positive 20. And that gives you 27. So 27 equals 27. Check. We did it. And that is a very short notes. I kind of talked a little bit longer than I would have normally for such an easy problem. We're approaching 7 minutes here, or a little past 7 minutes. Most videos are going to be between 10 and 15. And if it's longer than that, I cut it down so that there's multiple videos. So there we go. Stuff you already know. But I want you to practice a couple things. I want you to practice writing it very neatly. I want you to practice making sure your answers are circled, making sure you label that you're doing the check, and that your checks work out. And if a check doesn't work out, that's part of the process. If it doesn't work out, maybe you did something wrong, and you try to figure it out. All right, thank you. Have a good night, and make sure you bring those Cornell notes in on this video.